Okay, these tension questions always scare people, but they're actually really easy. But just looking at it, it looks really complicated because you've got tensions here, like you've got tension 1, you've got tension 2, and plus you've got this applied force, which may or may not be applied to a rope, which means you'd have a third tension. It doesn't really matter. Question says here, find the acceleration of the blocks and the tensions of the strings if, for the first one, if we have frictional forces that are negligible, and then if we have a force of 5 newtons on each block. Well, let's do the first part here. If the frictional forces are negligible, we can find the acceleration. We know it's going to go to the right. So all we would do for part A is just go F equals ma. Your overall force is 30. Your overall mass is 3 masses. So you go mass plus mass plus mass. So you would go 2 plus 2 plus 2. Solve it out for your acceleration. So you get 30 equals 6a, and your acceleration in the end equals positive 5 meters per second squared. So there's our acceleration. We want to find the tensions. What you do is you go back to the original picture. You circle which tension you're looking for. In this case, I'm going to find T2. Well, T2 is going to be F equals ma as well. You know your acceleration, you just found it. T2 is what you're looking for, T2. And your mass is 2. Your acceleration is 5. So tension 2 is 10 newtons. So that means this rope here is pulling this mass at 10 newtons. And tension 1 is mass times acceleration as well. So T1, your mass in this case, if we circle it, is these two things. Mass plus mass. 2 plus 2. And it's still being accelerated at this rate, which is 5. So tension 1 is 5 times 4, 20 newtons. There you go. I would not look at this 30 and go, well, 20 plus 10 equals 30, so this has to be right. That works only when the masses are all the same. If I gave you all these different masses, throw everything off. So let's see here. Did we find everything? We found the acceleration and we found the frictional. Okay, good. So we've done that. So part B has us doing all of this again, but now we have a frictional force. So I'm going to ditch this, come to another new one right here, and we're going to do part B. Part B is assuming this, that there's 5 newtons here, 5 newtons here, and 5 newtons here. This is still tension 2, and this is still tension 1, and that's still 30 newtons pulling it. So we want to find the acceleration first of all. So we go F equals ma. 30 is pulling it, but now it's actually 30, and we got to negate all of these 5s. So negate this 5 off, then negate that 5 off, and that 5. Your masses are all added, so that's 2 plus 2 plus 2 times acceleration. So 30 minus 15 is 15. Is equal to 6a. So your acceleration is going to be 15 divided by 6, which is positive 2.5 meters per second squared. Okay, now we want to find the tension. So we'll start off with tension 2. So we did what we do for this is we go, okay, well tension 2 is this right here. Not this 5 newtons because it's only applied to this block, but this frictional force, this tension, and that mass. So tension 2 is F equals ma. But this time, it's tension 2 negating this 5 for friction. Mass is 2 kilograms. Acceleration is 2.5. So you get T2 is going to be equal to 2 times 2.5 is 5, minus 5, add 5 to that side, 10 newtons. Sure doesn't feel right, does it? But good enough. Let's see, next we'll do this one. Tension 1 is including these two. So let's drop this down. It's T1 equals mass times acceleration. This is going to end up being then, let's see, tension 1 minus this 5 minus that 5. my mass is 2 plus 2. And my acceleration is still 2.5. So tension 1 is going to end up being 2, so 4 times 2.5 is 10, plus 5 is plus 10, which is 20 newtons. This 5 newtons doesn't come into play because we're not asked to find this tension. So there you go. 10 newtons, 20 newtons. So that's your forces of friction, how to do it. And this one was when you don't have any forces of friction. Okay, so remember, you are circling the ones that you're working with, and then you're just essentially going F equals MA. On this one, you're circling them, you're going F equals MA, but you have frictions in there. Remember, the answers on these look really symmetric because it's 2, 2, 2. When you get different masses, the answers really change. But this is a good demo on how to do these. Okay, there you go.